Perform operations on a known Maclaurin series to find the power series representation for each of these functions. Include the interval of convergence. So part A, we got x times e raised to negative 3x. So e raised to something, let's say ex. We know the power series for e raised to x, or Maclaurin series for ex, which is sum n from 0 through infinity of x to the n over n factorial, and it converges for all real numbers. Okay, we know that part. Now we need to find power series for this. So this one is same as x times e raised to negative 3x. So this x now we replace simply by negative 3x. So this will be simply negative 3x. Okay, so sum n from 0 through infinity of negative 3x raised to n over n factorial. Now we need to simplify this. So x times n from 0 through infinity of negative 3 to the n times x to the n, or we can write negative 1 to the n, then 3 to the n, and x raised to n, all over n factorial. Now this x means x raised to 1. We need to take this inside. We can combine with xn, and we know that x raised to 1 times x raised to n, x raised to, we add the exponents, n 1 plus n, which is same as n plus 1. Okay, so this one is then n from 0 through infinity of negative 1 to the n, 3n x raised to n plus 1 all over, or we can just write anywhere, just n factorial, and the interval of convergence is all real numbers. Okay, now part B is 4x times sine 2x. So for sine 2x, we can find the Maclaurin series in this way, sine 2x. So we replace this x by 2x, then this x is simply 2x. Okay, this is given. The Maclaurin series for sine x was given. Now we will write for sine 2x, then 4x. We need to multiply by 4x. So this is 4x times sine 2x. So right from there, sum from n equals 0 through infinity of negative 1 to the n, x means now 2x raised to 2n plus 1 over 2n plus 1 factorial, and this is converges for all x. Okay, now let's simplify. So 4x, let's leave outside for now. N from 0 through infinity, negative 1 to the n, okay, 2 raised to that number times x raised to that number, 2n plus 1, all over 2n plus 1 factorial. Okay, now we need to take this inside, so x raised to 1 and x raised to 2n plus 2, so we can multiply, means we add the exponents. So this is sum n from 0 through infinity of negative 1 to the n. Okay, here is 2 raised to 2n plus 1 and 4. If you like, you can combine. 4 is 2 squared and 2 raised to 2n plus 1. Okay, when we multiply, we add the exponent. So we can write 2 raised to 2n plus 3. And here x raised to 2n plus 1 and 1, 2n plus 2, all over, or just here, 2n plus 1 factorial. Okay, and this series converges for all x. In part C, we got the function 2x times cosine x squared. So here we got the power series or Maclaurin series for cosine, which is same as like sine x. Sine x got 2n plus 1. These are odd powers of x. And cosine got 2n, means even powers of x, like x squared, x4, etc. And here, all we have to do is cosine x squared means we replace this by x squared. That means this x will be x squared. Then 2x times, we multiply by 2x. Okay? So this one is same as 2x times this Maclaurin series, n from 0 through infinity, negative 1 to the n. Now x is in fact x squared raised to 2n over 2n quantity factorial, and this converges for all x, which is 2x times this power series, x squared 2n means we multiply x raised to 2 times 2n, 4n over 2n factorial. Now 2x times means that's the x raised to 1. Okay, we can take this inside and combine with 4n. That would be 4n plus 1, and we can take this 2 inside as well. So this Maclaurin series is negative 1 to the n, and there is 2 times x raised to 4n plus 1 all over 2n factorial, or we can just write here. Okay, we can't simplify here, just leave there like this. Okay, or you can make for everything, and the interval of convergence is still all real numbers, final.